Many people notice a strange pattern in their daily lives. They feel mentally alert late in the evening, even when the day has been long. Then, in the morning or early afternoon, focus and energy seem harder to access. Research in neuroscience and chronobiology suggests this experience is not accidental. Experiments show that artificial light changes how the brain receives timing signals that once structured mental energy across the day. This episode explores how modern lighting environments reshape the natural cycle of alertness and fatigue, and what science helps us understand about that shift. Later in this video, we'll look at how laboratory studies, observational research, and animal experiments reveal the ways light affects mental energy, not just instantly, but across the entire day-night cycle. The phenomenon researchers examine here is not simply brightness or darkness, it is timing. For most of human history, the nervous system relied on a strong contrast between daylight and night to organize when to be alert and when to wind down. Artificial light did not just extend usable hours, it introduced light signals at times when the brain once expected darkness. Researchers are interested in this because mental energy, attention, alertness, and cognitive readiness is closely tied to internal biological rhythms that evolved under predictable lighting conditions. For a long time, light was studied mainly as a tool for visibility. More light meant better performance, and darkness meant rest. In this earlier framework, the brain was assumed to respond mostly to how bright the environment was at a given moment. Over the last several decades, research shifted toward a broader framework. Chronobiology and neuroscience began to show that light is also a timing signal. It synchronizes internal clocks, shapes daily physiological rhythms, and influences mental energy beyond immediate visual effects. This work focuses on how light interacts with circadian systems and arousal networks, rather than treating illumination as a purely practical factor. Several lines of research contribute to this understanding. In chronobiology studies conducted at academic research institutions, scientists identified specialized retinal cells that respond to light and project directly to the brain's central clock. These cells influence circadian timing independently of vision. Human laboratory studies, including controlled light exposure experiments, examined how evening and nighttime artificial light affects internal rhythms by measuring hormone secretion, alertness, and physiological markers. Other studies simulated shift work conditions by exposing participants to light at night and observing changes in cardiovascular patterns and daily regulation. In parallel, laboratory experiments tested how light intensity and spectrum influence alertness during the day, often comparing bright, blue-enriched light with dim lighting while participants performed attention tasks. Animal studies in chronobiology labs examined the effects of repeated exposure to dim artificial light at night on brain structure and function over days or weeks. Across these studies, researchers measured circadian timing, melatonin levels, reaction time, subjective sleepiness, cognitive task performance, physiological signals, and neural changes. Several consistent observations emerged. Bright artificial light during the day can acutely increase alertness and improve performance on attention tasks. Blue-enriched light is particularly effective at activating alerting pathways in the brain. At the same time, exposure to artificial light in the evening or at night shifts or weakens circadian signals that once clearly separated day from night. This reduces the contrast between periods of alertness and periods of recovery. Studies simulating nighttime light exposure show changes in physiological regulation that extend beyond sleep, affecting blood pressure rhythms and other systems tied to daily timing. Animal research suggests that repeated nighttime light exposure can alter brain regions involved in memory and mood, though these findings come from non-human models and require careful interpretation. Observational studies in humans show associations between daily light exposure patterns and cognitive performance, but these relationships often weaken after accounting for lifestyle and health factors. Together, the findings suggest that artificial light reshapes mental energy by delivering mixed timing signals, enhancing alertness in the moment while blurring the daily rhythm that once organized when energy naturally rises and falls. These findings come with important limitations. Many human studies involve small samples and highly controlled lighting conditions that do not fully represent real-world environments. Animal studies offer detailed mechanistic insight but do not directly translate to human indoor lighting experiences. Observational studies cannot establish cause and effect, and light exposure often correlates with other factors such as outdoor activity or general health. Researchers continue to debate how much everyday indoor lighting meaningfully shifts circadian timing, how individual differences shape responses, and how acute alerting effects interact with long-term rhythm changes. The evidence does not show a single outcome for everyone. It shows patterns shaped by timing, intensity, spectrum, and repetition. If artificial light altered the signals that once structured mental energy across the day, what does that reveal about why alertness and fatigue now appear at unexpected times? If you're interested in understanding what science discovers about how modern environments shape the brain and nervous system, you can subscribe. This episode is part of the series Why Modern Life Feels Mentally Heavy. In the next episode, we'll explore why doing work you dislike affects more than motivation.